Welcome you all to the second part of Unit 14. So today our lesson is on sound. In my last video, I discussed with you about the properties of light. So there we discussed about the reflection and refraction of light. Now let's see how those properties can be seen in sound. So first let's see that what we know about sound, because from grade 6 you have learned about sound. So you know some facts about sound. So first we'll recall our memory regarding sound. As you know, sound is a form of energy. It is not a form of matter. So as a form of energy, it doesn't have a mass or it does not occupy any space in the environment, and it propagates in the form of wave. Propagation means traveling of sound. It travels from one place to another as a wave. And also sound is produced due to vibration. So vibrating different surfaces, you can produce sound waves. And for the propagation of this sound, it always needs a medium. So without a medium, sound cannot propagate as it travels as a vibration. So for vibration, for passing vibrations, there should be particles in the medium. So sound always needs a medium for its propagation, and its speed of sound. Speed of sound depends on the properties of the medium, such as pressure, density, and temperature. And the speed of the sound is very high in solid, and the speed reduces as it goes to liquids and gases, and the lowest speed can be found through the gases. So these are the things that you have learned about sound in lower grades. So now we'll see what we have to learn about sound in grade 9. So today we are going to discuss about the properties of sound. Earlier we discussed that what the sound is, but here you are going to learn the properties of sound. The main property of light that you are going to learn in this lesson is reflection of sound. So you know the term reflection because we learned the reflection of light in the previous lesson. So here we are going to learn the same concept that is related with the sound wave. So let's see what is reflection of sound. So reflection of sound is the process of bouncing back of sound when it hits an obstacle. So here the same thing happens as it happens in light. So when a wave travel and hits an obstacle, it bounces back to the same medium where it comes. So this process is called as the reflection of sound. So you have learned about the laws of reflection in the reflection of light. So here we are going to see whether this reflection of sound is also occurring by obeying the laws of reflection. So for testing that, you have to do a simple activity. So I have copied the video from YouTube. So to show that what you have to do to identify the reflection of sound and whether it obey the laws of reflection. So for doing this activity, you will need very simple items. So you will need two tubes. For these tubes, you can use two plastic tubes or two tubes made by cardboard. And also you will need a clock or a clock. So here you have to hear the sound of moving arms in the clock using these two tubes. And also you will need a protector. So let's see what you have to do. You have to place the two tubes and the protector on a flat surface as shown in this diagram, and you have to change the angle in between this normal line and one tube uh, um, to 20 degrees and place the clock in one end of it, and you have to change the position of the other tube, and you have to keep your ear in the other end and listen where you can hear the maximum amount of sound. So you will be able to see that the angle of incident you use is 20 and the angle of reflection you receive is also 20. So now again we have changed the angle of incident up to 40 degrees and keep the clock and hear the tick sound by moving the other tube, and when you keep it at the 40 degrees you will hear the maximum amount of sound. So again it confirms that the angle of incidence is equal to the value of angle of reflection. So again let's see, by moving the angle of incident up to 60 degrees. So when you keep it at the 60 degrees and keep the clock, again you have to change the position of the other tube, and when you keep it at 60 degrees again you will hear the maximum sound. So here again it proves that the angle of incidence is equal to the angle of reflection. Both the values are equal to 60 degrees. And now let's keep the angle of incident in 90 degrees and see the value of angle of reflection. So again, when you change the position of this tube, you will hear the maximum amount of sound when you keep it near 90 degrees. So again, it proves that this angle of incidence is equal to this angle of reflection. In this activity, it proves that the sound waves also obey the laws of reflection as light waves did. So, reflection of sound also occurs by obeying the laws of reflection. Okay, now let's see what are the phenomena associated with this process of reflection of sound. So, there are two main incidents that occur, or two main phenomena that occur due to this reflection of sound. The first one is echo, and the second one is reverberation. So echo and the reverberation are the two main phenomena that occur due to the process of reflection. So here in this diagram, you will clearly see that there's a teacher and there are few students. So in this black arrows, it shows how the sound of teacher travels directly to the students, and also using this orange color waves it shows how the sound of teacher hits on the surfaces of the room and reflected and come to the students. So uh, here the direct sound also come to our ears and the reflected sound waves also come to the ear. So um, the way of receiving these two types of waves causes these two phenomena, echo and reverberation. So we'll see what is echo and what is reverberation in details. So first we'll discuss what is echo. Echo is the second hearing of sound due to the reflection of sound after the first one. So if you make a sound, so you will hear that sound and it goes and hit a surface and reflects and then come back to you and you will hear the second sound. So you will hear the same sound in two times. It repeats. So this process is called as echo. So for example, if you say hello, uh, due to echo, you will hear it as hello, 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 hello. So this is echo. If you say the word hello by standing in your room, you will not hear as hello, 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 hello. But if you go and stand up near a mountain range and say hello loudly, then you will hear that sound back. This is due to the reflection and the process of echo. So let's see why this phenomenon occur and what is the reason for causing this. For that also I have used a simple video copied from the YouTube, and we'll try to understand what is echo using this video. So here also it says that echo is the repetition of the same sound again and again by the reflection. So here uh, there's a child and he makes a sound by clapping, and in front of him there's a barrier. So uh, the sound of clap or the sound waves produced by clapping travels in air and it hits the surface. So while it travels, the sound waves comes to our ear also. So you will hear the first sound hello, and when it hit the surface and comes back, again you will hear another hello. So you will hear two words or same word in two times. This is due to the echo. So if you want to hear the same word twice due to the process of reflection of sound, there should be a maximum time gap of 0.1 seconds between the two sounds. So when the distance between you and the obstacle is uh, more than 17 meters, then that sound can maintain the time gap of 0.1 second. So that is why you hear the same sound again and again. So I think you will uh, understand it clearly here. The distance between the person and the obstacle is 20.5 meters. That means it is more than 17 meters. So if the person makes sound, he can hear the repetition of sound as this distance is more than 17 meters. So if this distance is more than 17 meters, again it can maintain the time gap between the sound you create and the reflected sound as 0.1 seconds. So you will hear the echo. So this process is called as the echo that occurs due to the reflection of sound. But the sharpness of sound that you hear after the echo is lower than the sound you create. That is because some energy of the sound is absorbed by the surface of surface when it hits the surface, and uh, the rest sound energy is reflected back and come to your ear. So that is why you hear it as hello, 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 hello. So this is the process of echo. So now let's move to the second phenomena associated with reflection of sound, that is reverberation. So here it is the process of persistence of sound. Here, the sound persists within the ear for a long period of time due to the disability to distinguish the original sound and the produced echo. So this process is called as the reverberation, and it is clearly explained in this diagram. Here, there's a sound source and it produces a sound, and that sound directly travels through the air and it reached the ear of the listener, and also that sound travels uh, throughout the atmosphere or the air in this room, and hits the walls like this and get reflected, and this reflected sound waves also reach the listener's ear. So uh, as these sound waves comes to the ear with the time gap of 0.05 seconds, this listener cannot identify the direct sound or the original sound and the reflected sounds separately, and he will hear that sound as one sound, or this is called as the persistent of sound. So if you say the term hello, after the process of reverberation, the person will hear it as hello. So it persists for a long period of time. So you may have heard this phenomenon, or you may have experienced this phenomenon in the places like auditoriums or cinema halls. So there it has a larger area, or the holes are very large. So uh, it creates this reverberation. So to hear the echo, there should be there should be a time gap of 0.1 second to second in between the two sound. Here the gap is half of the echo. So if the time gap between the two sounds is 0.05 seconds, so that sound persists in the ear for a long period of time, and it causes the reverberation. So to occur the reverberation, the time gap between the original sound and the reflected sound should be at least 0.05 seconds. Um, so now let's see what are the methods used to prevent the process of reverberation in the cinema halls and auditoriums. The first one is making the walls rough. So by making the walls rough, it increased the absorption of the sound waves by the walls. So as the sound waves are absorbed by the walls, the amount of sound that reflects reduces, and this causes to prevent the reverberation. And also it creates the ceilings of these holes as porous. So this also prevents the reverberation. And also uh, hanging rough folded curtains. These curtains of these halls are folded in uh, large large folded curtains or rough folded curtains can be seen in this hall. So for example, in your school auditorium also, it has this rough folded curtains and rough walls. So the purpose of doing these things is to prevent the reverberation. So these things helps to absorb the sound waves in large amounts and reduce the amount of sound that reflects and come to the ear of the listener. So by doing these things, it has reduces the reverberation in cinema halls and auditoriums. So now let's see how this reflection of sound is useful in our day-to-day activities. So the first instance of using this reflection of sound is ultrasound scanning. So in scanning internal organs or in observing the internal organs, we use this ultrasound scanning. There, uh, so ultrasound waves are generated by a machine, and that produced ultrasound waves are aimed at the relevant organ from the outside of the body. And these ultrasound waves hit the organ and reflected back, and that reflected waves are detected by the machine, and the formulated waves are created on the machine as the appearance of the organ on a screen. So this is used in observing internal organs and observing the womb of a mother, pregnant mother, and it is very useful in medical field. And the second main instance of using this reflection of sound is the finding the depth of the ocean bed. So to find the depth of the ocean bed also, it uses the ultrasounds. There it creates the ultrasounds by a equipment called as echo sounder, and that sound waves travel through water and hits the uh, bed of the sea, and after hitting, the sound waves get reflected, and that reflected sound waves are also detected by this equipment. And uh, by measuring the time taken to receive this reflected sound wave and the uh, speed of sound waves through water, it calculates the depth of the sea. So the method used here is called as sound navigation and ranging system, or sonar system, and the equipment used here is echo sounder. And another natural instance of using this phenomenon of reflection is uh, by animals. That animals like bats and whales use this reflection of sound waves to identify the obstacles. So bats produce this ultrasound, and that produce ultrasound. So in this diagram, the ultrasounds produced by the bat is denoted by this white color, and it hits the obstacle or the uh, prey, and the reflected sound waves are denoted by this yellow color, and this bat detect the reflected sound waves, and it uh, imaging the distance to the obstacle or the prey and the nature of the obstacle or the prey using this reflected sound waves. And this method is used by the aquatic animals like whales and dolphins, and this method is used by the modern equipments like submarines, modern vessels like submarines, to detect the distance between the land and the vessel. So these are the instances where reflection of sound waves are used in application. Okay, now let's try to summarize our today's lesson. So let's see what we have learned through this lesson. So here we discuss about the sound, and as a main property of sound, we discussed about the reflection of sound. So reflection of sound is the bouncing back of sound after hitting it on an obstacle. So due to the reflection, it occurs two phenomena as echo and reverberation. So in the lesson, we discussed what is echo and what is reverberation. And when we come to the reverberation, uh, it creates some troubles in the auditorium halls, cinema halls, and lecture halls. So to prevent the effect caused by the reverberation, it has taken some preventive methods. So also we discussed those preventive methods in the lesson, and also we discussed the applications of the process of reflection in our day-to-day activities. So here's the summary of what we have learned, and I think uh, you will be able to get some idea about the reflection of sound by watching this video. Okay, now we have come to the end of our lesson, and we'll meet with another new lesson in my next video. Goodbye, you all.